Here are solutions to homework set number 1 for ECE 111, Introduction to ECE. The first problem asks you to go to Bison Academy to look up the solutions to a previous set. So last semester we looked at how to solve 2 equations, 2 unknowns in homework set number 2. This semester we can just go to Bison Academy and find the answers. So if you ever get stuck on a homework problem in 111, a good place to go are homework sets and solutions. If you go to Bison Academy, the semi-official website for a department, under 111, Homeworks and Solutions, here are the homework problems from previous semesters. Now the homework problems change every semester, but you can kind of see the approach used to solve the previous problem. It's probably going to be pretty similar to solve this problem, this semester's problem. So if we go under, and I forget, Homework Set 2, Fall 23. So here is Fall 23, Homework Set 2. Scroll down to problem number 2. Here's the answer. So you can just copy and paste that. What this is given 2 equations, 2 unknowns, one way to solve is to plot them. And the intersection is the solution. That's something we'll go over next week on homework set number 2. But for now, I can just say, well, according to the previous solution, here's the answer, copy and paste. Problem number 2. Find the roots to a polynomial. Well, if I plot x versus y in Matlab, what you're going to wind up with is some function kind of looks like this. The 0 crossings are the roots. Matlab has a function to find the 0 crossings or roots. It's spelled roots. So you first input the polynomial. The notation that Matlab uses is it treats this as a matrix where the coefficients are the entries in the matrix. So this would be 1 x cubed minus 3 x squared minus 64x 192. Basically, Matlab is a matrix language. You can input matrices really easy. Polynomials not so much, but this matrix represents that polynomial. Once you have that polynomial or matrix in Matlab, I can find the roots to that polynomial, and here are the roots. If you have a 4th order polynomial, just input the coefficients, 1 minus 15, 23, 315, minus 324. Find the roots. Here's the roots of that polynomial. This is a 4th order polynomial that kind of looks like this. This has 4 roots, 4 0 crossings. 5th order polynomial, input is 1x to the 5th, minus 17, 21, 837, minus 3402. Find the roots. This has 3 real roots. I'm missing one. I missed a term. Plus 0x. There needs to be another 0 right here. If I do that, I'll get 5 roots, 3 real ones, 3 real ones, 2 complex ones. So if you plot this, a 5th order polynomial, 1, 2, 3, kind of does this. It has 3 0 crossings, and this one doesn't have a 0 crossing. That's the complex root. Actually, 2 roots at 9. Just hits the axis. That's problem number 2. Problem 3. You can use Matlab like a graphing calculator, or just a calculator. Problem 3 is use Matlab like a calculator. If I have these equations, I want to know what is the value of r and v when lux is 30. Just plug it in almost the way you type it. So lux is 30. Matlab is case sensitive, so if I use capital L, I've got to be consistent from then on. R is almost the way you type it. 5,000 times lux to the minus 0.6. 649 ohms. Once I know R, I can use that in the next equation. R over R plus 500 times 5, 2.82 volts. So you can use Matlab just like a calculator. Bit of an overkill, but it works. You can also do graphics with Matlab. Oh, okay. 100 lux, same thing. Change lux to 100, type it in again. It's now 315 ohms, 1.93 volts. Problem 4 is I can use it as a graphing calculator. If I want to do a whole bunch of numbers at once, what I can do is this. This command has you go from 10 to 100 steps at point 1. So this has 1,000 points in this matrix. To find the resistance, instead of doing power, I got to use the dot hat. This tells MATLAB, don't treat that like a matrix, treat that as 1,000 different numbers. Take each number separately, raise it to the minus 0.6 power, and then plot it. Here labels the axis, and here's what you get. So this is the lux versus resistance. What that tells you is, if we read off the graph, at 30 lux, I'm at about 650 ohms. At 60 lux, I'm about 420 ohms. Or going the other way around, at 900 ohms, I'm at about 18 lux. I can do a function of a function. If I convert from resistance to voltage, again lux, calculate resistance. Once I have resistance, calculate voltage, again using the dot notation. Telling MATLAB, treat this as 1,000 separate calculations. Do them one by one. Then plot lux versus volts. Here's what it looks like. Again, what I can do with this graph then is, given the voltage, I can tell you the lux. If I'm at 3.2 volts, here's 3.2, I can tell you what the lux is. It's about 18. At 2.2 volts, I can tell you what the reading is. It's about 70. Problem 6. This is where we're starting into for loops. A for loop executes a set of code a fixed number of times. So for example, let's have two people playing a game. A rolls 8 6-sided dice, takes the sum. B rolls 2 20-sided dice, takes the sum. Whoever has the highest score wins. Play a game or a match consisting of 5 games. What's the chance that A is going to win the match? Well, to start out, this is where the script window comes in handy. If you do File, New, Script, I get this window. This is a set of code that I can run just by hitting Run. It lets you build a program. So if I tried solving this all at once, I'd get frustrated. But let's kind of do it in steps. Let's start out with A rolls a 6-sided die. So if I do that, let's stay somewhere. Call it problem 6. Run that, I get a random number. Let's generate, I forget. Come on, puppy dog. 8 6-sided dice. So let's generate 8 random numbers. There's 8 random numbers. Let's make them numbers 1 to 6. Looks good. Let's round up. Gives me integers between 1 and 6. Now let's take the total. So this is my 8 6-sided dice. Once I'm convinced that works, let's do the 20-sided dice. Get the numbers between 2 and 40. Looks good. Okay, so that's a single set of dice. I'll then check. If the 6-sided dice is more than the 20-sided dice, A1. If it's a tie, everybody gets half a point. Otherwise, he gets a point. Okay, so that's a single game. And let's just see what the result is. Let's display A, the D6, D20, A, and B. And try that, see if that works. So I had an error. I have to declare my variables before I use them, starting with 0 points for A, 0 points for B. I got 21 versus 13, A1. 28 versus 30, B won. And keep on going. Eventually get a tie. Not real good odds of a tie. Oh, there's a tie. Okay, so you can get ties. Looks like that works. This is for a single game. Now let's do a 5-game match. Here's a 5-game match. Indentation isn't required in Matlab. It just helps you understand what's happening in the code. So I start indenting it. So here I'm done indenting. Here's my for loop for a 5-game match. I'll play 5 games. Then at the end of the match, if A is ahead of B, A won. If they're equal, it's tied. If otherwise, lost. So let's display A, B, wins, ties, and losses. Run that code. So here, as I run the code, here's the wins for A, wins for B, and they should add it up to 5. They don't. Which tells me I put this in the wrong spot. This is pretty common when you write the code. I made a really subtle mistake. I put the clearing inside the loop rather than before the loop. So every time I go through, I clear the game, clear the score. Now when I get that right, the match ended up 4-1, A won. 5-0, A won. 3-2, A won. Let's make sure can B ever win. 3.5 to 1.5, 4-1. Does A ever lose? Well, not real likely. Oh, there it is. 2-3, A lost. Okay, that's for single match. What's the chance that A is going to win overall? That's Monte Carlo. Let's take this and throw it inside another for loop, play 100,000 games. So here I paused the video as I added this loop, for loop, indented everyone. So this is play a single match. Now let's play 10 matches. We'll play 10 matches and see what the wins, ties, and losses are. As I run it, it was 8-2. So the total is 10, and A is winning most of the time. It's changing. Here's the tie. Pretty happy that that looks like it's working. Once I'm fairly convinced that works, now let's play 100,000 games. 100,000 games takes a little bit longer, but A won 89% of the time, tied 2.5% of the time, lost 7.7%. That's a for loop. And kind of notice when I wrote the code, instead of writing the code all at once, kind of go in steps. That's where Matlab is really nice. I can sit there and write the different sets of code, display data as I'm writing it so I can see what's happening. Sometimes you make mistakes. When you display the data, you can see, gives kind of a hint where the mistake was. In this case, I put the clearing inside the loop rather than outside of it. And eventually I wind up with actually a fairly complicated program. So this is the chance that A is going to win a 5-game match, 89%. What wasn't asked for is I can now change it. Let's play a 1-game match. In a 1-game match, A wins 74% of the time. A 17-game match. Again, I would not want to calculate these odds. But with Matlab, if I can do 5 games, I can do 17 games. It makes it really easy to modify the code. That's where scripts are nice. 17-game match, A's got a 98% chance of winning. That's problem number 6. Problem number 7. I'm going to play a match consisting of 5 games. A's got a 65% chance of winning any given match, any given game. What's the chance that A wins the match? So what I do is first play a single game. Pick a random number. If it's 0.65, 65% chance that A wins, otherwise B wins. That's a single game. Throw that inside a for loop, and now play 5 games. At the result of 5 games, if A is bigger than B, I won the match. Otherwise, tied, lost. Now, once that works, play 100,000 games. And here, A won 76% of the time, never tied, lost 23%. That's a for loop. Problem 8, a while loop. A while loop is different than a for loop. A for loop, you play a fixed number of games. With a while loop, you keep going until somebody wins. So for example, go back to problem number 6. That's what we had before. If I can get there. So problem number 6. So here's the game. I play a match, and the match consists of 5 games, period. That's the for loop. I always play 5 games. A wins 89% of the time. A while loop, all you really change is this one line of code. Keep playing until somebody is up by 3. What that does is now, it's now 97% chance that A is going to win. I can kind of see what's happening if I see what goes where. There's the end statement. And let's just do 10 games. I'm going to display the end of the match scores. So here's the score of 10, A versus B. So when I do that, A won 4 games to 1, 3 games to 0, 15 games to 12, 3 to 0, 3 to 0, 9 to 6. Somebody's always up by 3. And does B ever win? B never wins. But the match can go on for quite a while. That is win by 3 versus win 3. Once I'm convinced that works, I take out my display. Here's a comment in Matlab. And go back to 100,000 games. In 100,000 games, B won 2,519, 2.5% of the time. That's problem number 8. Problem number 9 is almost identical to problem number 7. So going back, here's problem number 7. Let's clear the screen, that's CLC. And problem 7, here is a single game. A's got a 65% chance of winning a given game. Play a 5-game series. If A is up at the end of the 5-game series, it's won, tied, or lost. This is a for loop. I play a fixed number of games. If I change this to a while loop, keep playing until somebody's up by 3, the odds suddenly become 86%. And again, if I want to see what's happening, I could throw in a display statement. At the end of the match, let's just play 10 matches, see what the score is. So here in the match, A won 11, A lost 11 to 14, A won 3-0, 3-0, 3-0, 8-5. The number of games in the match can vary quite a bit. That's a while loop. Keep playing until somebody's up by 3. Once I'm convinced this works, I'll comment out that statement, play 100,000 games, and in 100,000 games, A wins 86% of the time. So that is homework set number 1 for ECE 111. Again, the point of the course is getting used to Matlab. It's probably a little bit clunky, a little bit not really sure what you're doing yet. Again, this is the first homework set you've had in Matlab. That's not unusual. As you start programming in Matlab, you'll kind of get the hang of it, get how the commands work. Matlab's actually a very, very friendly language. But the tricks that I'm doing in here, rather than write the code all at once, build it in pieces. Keep on building up to get the program, display what's happening as you go along, and fix your code as you write it. That's one way to write code, get something that works without too much time commitment. It doesn't take that long to write the code. If, on the other hand, you try to write the code all at once, if you're like me, I'll make mistakes, I'll get really frustrated. Take baby steps. That's one trick in programming. Check your code as you write it. Write it in small chunks, check your answers, improve the code, check your answer, build on it, check your answer. And by doing so, you can write the code in probably like an hour or 2 for these homework sets. That's homework set number 1 for ECE 111.